Over the last couple of months, I have been working with my version 0.20 of my 286 PCB or system board, or maybe you call it a motherboard. I now have queued up enough changes to that I think I'm going to order an updated PCB. And so I thought I would just real quick walk through some of those changes that I am going to be introducing with this latest version. And so here is my current PCB that I've been working off of. So it's like I said, it's a 0.20 is the version. And what it really looks like then as I've populated it is this. And the two cards plugged into it, of course, would be my video card, my sound card. I have a Nano on the lower left that's helping me deal with the USB mouse. The lower right, I have this Arduino Duo that's just basically doing remote updating or onboard programming of my flash ROM chips. And as I look at the changes I'm going to introduce to this is the list that probably is the most notable stuff. So first of all, updates to support the onboard flash BIOS updating. So I've had to change some of those signals, especially the write enables for those flash chips, along with connecting in this Arduino Duo so that for my PC I can communicate to the Duo, and then from the 286 it can pull the latest BIOS information off of that Arduino Duo and update my flash memory. Now, one thing with that Arduino Duo is I've had to use an in-between board that does voltage level shifting from 5 volt on my 286 to the 3.3 volt on my Arduino. And so I've actually added that level shifting right onto the system board so that it's not a separate board to do that. I am not actually placing any Arduinos on the latest version. I actually removed, and I didn't list that here in the bullets, but I removed the Arduino Mega from the footprint of the board. And I have also not made a space for the Arduino Duo. So you'll see that when I get to this updated version 0.50, it's pretty full. There really is not room to place an Arduino on the board. So if I do want to use those, they'll just sit off to the side and connect through a wire or wires accordingly. I did add the PS2 mouse connection, both a PS2 connector and a USB connector, either of which will take in the mouse input for my computer. Now, keep in mind, I am only using the PS2 protocol, so even when I plug it into the USB slot, it's really just falling back into compatibility mode and using the PS2 protocol. And so I know that I have a USB port that really is just a mouse port, but it's convenient for me to be able to plug my mouse in that way and not need an adapter. And then I've added the Arduino Nano that does that mouse processing. Well, as added though, I also took my keyboard signal, the two data lines for that coming from the PS2 keyboard connector, and also brought that to the Nano. Now on my updated system board here, I still am leaving the discrete ICs that let me do PS2 keyboard processing, taking in that data and raising an interrupt. But if I can get that functionality working on the Nano with this new version, then I can depopulate or not populate that portion of the board. And then in a future revision, maybe take away those ICs that are doing PS2 keyboard initialization and fetching of the data and raising an interrupt to my interrupt controller. So I think I could actually pull out at least 3-4 different ICs that are all doing keyboard stuff if I use just a single Nano for both the mouse and keyboard. But short version is, in this build, I have the keyboard data coming in both to my legacy circuit and to the Arduino Nano. So if I want to try to get that working on the Nano, I can then disconnect the old circuit if I want to do that. I did add an additional priority interrupt controller. So this board that you see here, the existing .20, has a single pick. I now have dual picks on the upcoming board. I also started to implement DMA support, and I'm going to talk a little bit more about that in an upcoming set of slides. I did add a pair of serial EEPROMs. They're 256 kilobytes each, and that allows me just to have half a meg of EEPROM storage. I'm not going to use it for the ROMs for the computer, but maybe just if I want to store user settings or data or other things that don't really need a high speed transfer, I can store those assets there in those serial EEPROMs, and those will be read-write at runtime. I did add in a clock driver, and so instead of running off of my clock generator IC to all of the different clock destinations, I'm actually running that into a driver that then separates out 10 separate lines, and I'll show a little bit about that in the actual schematic here coming up. I did change it to an ATX form factor. I've mentioned that in previous videos that at some point I'm probably going to go to an ATX layout instead of the layout that you see on the screen. You know, the one for my .20 board really was just how I laid it out. There was really no rhyme or reason. I just was kind of building it out as I went. But now in the new version, I am going to an ATX form factor, including an ATX power connector and a switch for the power for ATX. And I added 4 more ISA slots. So I will have a total of 6 ISA slots in this updated build. And then I did a bunch of miscellaneous little things like adding additional power headers. I added basically some jacks by the ISA slots that allow me to run supplemental power to an ISA card if I want to do that. Many of my ISA cards at that one end of the card, I put on a connector that allows me to run a higher gauge set of power into it off of the system board or from the power supply. I haven't needed it, but I put those connectors on just in case I ever find myself having a power distribution problem. Maybe let me step in just real quick on the DMA controller. I do have some of these OKI 82C37s ordered up. And so this is a DMA controller that I'll be adding to my system. I don't have super high confidence that I have this connected entirely right, but I'm going to try something, and if it doesn't work on the next revision, I can adjust it accordingly. As I've looked at different documentation, I found this one from some NEC literature, but it shows kind of how this DMA controller would be connected into an 8088. And I'll show you my version of that, basically how I'm going to connect that in, and that would be what you see here on the left. So I've added this 82C37, and I've added with that a latch so I can go from reading my data into the upper address bits or the upper byte. And if I look at the diagram to the right, that would be this, what you're seeing right up here, where I'm going to read in data and then be able to latch that and put it back out on the address bus. You know, all these other signals, I have my bus controller that's providing those. So pretty much what I've used is this schematic sample that I found in the NEC documentation. You know, when I look at my addresses, I'm connecting A1 off of my bus. So this is basically a buffered or a latched A1 into A0, working my way up from there. As far as the data lines, I'm pulling those pre-latched, so that's kind of my internal data bus. And as I understand it, that's probably how this should be connected, I believe. And then I've connected all these other signals basically to match this diagram off to the right. So if I have this correct, and like I said, I don't have super high confidence that this is quite right, but this is the best I understand it today, so this is what I'm going to try. Then I'll have to get into all the coding of how do I actually programmatically set up this DMA controller, and then I'm going to need some type of a device to actually leverage DMA. I don't have any devices right now that require DMA. However, I'm getting into storage, and the first thing I'm going to do with storage is try to get a CF card working, compact flash card, as a type of storage. And maybe with that, I can start getting into DMA, or I'll find other circuits that I can start trying to build and test out DMA functionality. And then I have routed all of this through my ISA slot. So now my ISA slot will have DMA support, at least for as many DMA channels as this controller would support. I do notice on the ISA spec there are additional DMA, higher DMA numbers, these DAC and DRQs that probably require an additional DMA controller if I'm understanding it. And I won't support the highest numbers of those, so I will support though up to what this chip will provide me. So DRQ 0 through 3 and DAK 0 through 3. And so it probably means I'm missing 4 through 7, and maybe at some point in the future I could add those if I need them. So here is the schematic for my system, and you can see that it's less busy because I have started breaking out some of the pieces into their own sheets. So then here on this sheet, you can see that I have my interrupt controllers. So I have my initial interrupt controller. I've added an additional interrupt controller. I've set it to be a slave versus this one being a master. I'm cascading from the slave down here into the master on IRQ3. So I think I have that connectivity correct, the best I can tell from the data sheets. So that's something I now can expand all the way through IRQ15. And so we'll see how that plays out as I get in and test that and see if I got that all connected correctly. You know, if I go back to my keyboard and mouse, you know, I did go back to the Nano and I brought in the PS2 data and clock lines for my keyboard into a couple of the pins, plus the previous mouse data into a couple of pins. You know, the mouse, those lines have pull-ups here. For my keyboard, the pull-ups are elsewhere, so I didn't show them on this specific schematic. I've added the PS2 connector basically for the mouse, and the PS2 keyboard connector is shown back on my core sheet, so I didn't add that over here. I probably should move it. And then I also have this USB connector, so I can plug the USB or PS2 in and get that mouse connected up to my Nano. As far as ISA slots, you can now see I have 4 ISA slots, and as I go in and look at a single ISA slot here, there really aren't many signals I'm not using at the moment. I have a -5, and then my 12-volt negative and positive, and I'm not bothering running those through the bus at the moment because I really don't need them. I do have a pin header, though, that if I want to add those later, I can do that, and that's easy to do. And you'll actually see that when I get to my ATX power connector here, I did put in some larger type of connectors with those additional signals, so the 12 volt is there. So if I ever do want to connect 12 volt into that ISA bus, it's just a quick jumper wire that's going to let me do that. Same with the -5 volt or -12 volt. But other than that, I have most of these lines now connected. You know, I mentioned that as far as DMA controller, I don't have the 4 through 7. So if I go to my DMA, you'll see that those I'm just running to a pin header for now, so that if I do later want to choose to do something differently, I suppose I could put on an additional little daughter card with a DMA controller and fill in the rest of those signals. But these are the ones that are unsupported as of right now. So I'll support 0 through 3, and then 4 through 7 will not be supported. And then my programmer for my onboard flash update, I'm just putting a header off to the side that has the connections that will connect to it. But then I'm doing all the leveling, the voltage leveling on my system board. Plus I have 4 available pins to do additional leveling. So if I want to add another SPI device that needs 3 volt, I have that availability already on the board with a pair of headers to support that. So if I go through all of that, that gets me to this type of view. And you can kind of ignore these things off to the side. As I do my routing, I'm still using an auto router because this would take me forever to do manually, and I've been happy with the auto router I'm using. But I pull these over to kind of give me an edge cushion that it can't route within. So I just pull these off to the side when I don't need them. And I'm doing copper fill, and that's what these 2 shapes are right here is my copper fill, top and bottom, VCC and ground accordingly. But that gets me to a photo view of what this is going to look like, and maybe I'll just flip over to the 3D view real quick. So this is a fully routed, ready to order board. Probably what I'm going to do yet is do some measurement validation. You will notice that this is pretty much an ATX form factor, and I say pretty much because I'm maybe slightly a little bit wider, just by a little bit on the right-hand side. But all of these mounting holes are standard ATX. All the ISA slots should be in the proper location. In my 65816 build, I had one more ISA slot down here, but I needed room down here for this Nano. And so what you're going to see here is that, I have my LCD, I have an ATX power connector over here, along with the unused voltages coming to these other little headers. If I ever do want to use those, they'll be available right here. This switch goes to the appropriate pins on the ATX to turn on or off the power supply. Reset is my normal reset for the system. I'll have ZIF sockets right here, even though I probably don't really need them anymore with the onboard programming. I still like having the ZIFs in case I mess up the onboard programming of the flash chips. I can pop them out easily. So I've got room for ZIF sockets. I have my RAM. I have address and data headers for all the internal address and data in case I want to do some debugging. For example, hook up an Arduino to debug. When it comes to my Arduino do and the onboard programming, that header is sitting actually right here. So I just have this and I can set my do off to the side. All my SPI stuff can plug in here. And again, I've got 4 pins extra I can run into this leveler, and I've got 4 pins coming out, looks like down here. So pins in and out as far as leveling if I want to take 5 volt down to 3 volt. I have my math coprocessor. Here's my DMA controller. Here's my dual picks, my SD card reader way down here at the bottom. Here is the Nano that's going to get me into keyboard and mouse control, along with all of those pins also being exposed through these headers in case I want to do other things with them. I've tried to make room so that when I plug in this ISA slot, if my card requires to go all the way down to the PCB, it'll fit here. And then I should be able to also fit those types of cards here, here, and here. It's tight, but I should be able to fit those. And most of my ISA cards won't drop down that low, so then they can sit in these slots where I have other circuitry underneath where the ISA card is going to sit. So I think I'll be fine to be able to plug in my current 2 cards and 4 additional cards in the future. A couple of PPIs, my processor. Here is a chip that's going to do that clock distribution. So it's going to get out of my clock gen into it, and then it's going to run for every ISA slot. It has its own private clock connection back to this chip. I will experiment with that, and if the whole thing falls apart because of timing, I do have a set of headers here that I can actually connect the clock off of where it is now to everything like I have it in my 0.20 board. So worst case, if this chip does not work out the way I'm hoping it will, I can still revert back to the way I've been doing it and not have any concerns. For a little bit of space saving, underneath my PSOC, which is socketed right here, I actually put some chips underneath it that allowed me to free up a little bit of space on the board. And these headers bring this PSOC up so high, I've got plenty of room to put a couple of chips underneath it there. I think that's about it though. I did copper fill, and you can kind of see where that's coming through on this, and maybe I'll flip to the photo view. I think you can see it better here. So any of the solid blue, the lighter blue, that's all copper fill. That's the front side, and if I go to the bottom side, you can see that there's a lot of copper fill. So I don't think I'm going to have any power distribution issues. We'll see. I did have to bring down my VCC and ground size though, because when I got into, I was running 1mm on the previous board, but I can't run 1mm into these, what are these TSOPs, the small surface mount type device, because the traces were too big. And I figured I don't need 1mm going to all my power and ground if I've got that copper fill. So I actually dropped it down to 0.6. So I'm at 0.6mm for my VCC and ground throughout the board. And I think that, again, given the copper fill, I have no concerns with that. I think the copper fill is going to distribute things pretty nicely. And it looks like I've got overall pretty good coverage on copper fill. That, again, is the back, and this is the front. And I can flip this around and you can see what that looks like in the back, but I think that should all be fine. Or I'm going to find out, I guess, as I test it. So that's probably where I'm at, and that is a walkthrough maybe of what this planned board is going to be. When I do go to order it, these are $10 a board, so I'm going to get through this additional just validation of sizing and placement and all of that stuff, and maybe go through the schematic one more time and try to see if I'm missing anything else. But when it comes to ordering these, let me just pull that up. Yeah, it's $51 for 5 boards, and so I'll get those ordered up if everything looks like it's checking out okay. And I probably will not expedite those, so I'll just order them through slower shipping, and maybe sometime in April then I can come back to this board and start populating and testing some of this stuff. So that is version 0.50. If you have anything you're catching that I should be reconsidering or suggestions, do let me know. But this is the next incremental improvement in my system board for my 286.